Well, good morning, everybody. Hopefully, you can hear and see me okay. If you can, please say hello in the chat, both to me and to everyone else who is also watching this lecture right now. Let's see how that goes. If anyone say, aha, people are typing. Excellent. Good morning. Good morning. Hello. Hi. Excellent. It's lovely to have you here. Before we get started on today's lecture, there are a few things that I want to mention. So announcement type things. So exercises 0 and 1 at this point, you should have marks back for those. You may find for exercise 0, I think in Gradescope you'll have a number of either 0 or 1. And in the D2L grades, you should have a mark of 0 or 1. I think I managed for exercise 1 to let you have a mark that ranges from 0 to 10 in Gradescope, but still in Brightspace, you have a mark of 0 or 1 because you either completed it or didn't. And for the exercises, again, I'm not recording marks for correctness. It's about doing the exercise, making sure the tools work, making sure you can think through the issues, etc., and getting ourselves all warmed up for later assignments. So you should have those grades now. If anyone hasn't completed exercise 0 and 1, I know a few people emailed me about they had particular reasons why they couldn't submit on time. In some cases, it was computing problems. In some cases, it was things like a COVID shot hitting them like a ton of bricks. And I know exactly what that feels like, so don't worry. And basically, anybody who emailed me with a reason why they couldn't submit on time, I was happy to find a way to accommodate them. If you didn't email me and you also didn't submit exercises 0 and 1, then, well, at this point, if you have a very, very good reason, then we may still be able to do something, but otherwise that ship has sailed. And you didn't have to get the answer right, you just had to submit something. And these things aren't worth a lot of marks, but they're worth something. So I think if you didn't submit exercise 0, and you didn't submit exercise 1, and there are a few people in that category, I guess the best mark you can get in the course is now 99. Now, if there's a particularly good reason, and in this age of COVID, lots of people have extremely good reasons for things, do let me know, reach out, and we can figure this out. But I will not be, at the midterm break, going back and retroactively allowing people to submit exercises from the first week of the course or top hat questions that they didn't do since the beginning of the course, because that is a huge amount of extra work for me to click through and, okay, add this exception for this person, add this exception for this person. We're going to keep short accounts here. Now, again, if you have an exceptional reason, and some people do, unfortunately, death in the family has gone from a fairly rare reason for people to miss work to, unfortunately, a fairly common reason. And there's usually in a large class at least one person, and it's very sad. So, you might have an exceptional reason, in which case it's fine. Get in contact with me. But if you don't talk to me until 4 weeks into the course, then, well, there's probably not much I'm going to be able to do for you about week 1. Okay, so we've got lots of messages in the chat, and they're all just hellos and good mornings, and yes, excellent, welcome. I'm very glad that you're here. So that's exercises 0 and 1. Other things, so you've heard lots of developments around things like on campus activities. We are going to start the labs this week because our very, very hardworking, diligent people in engineering computing services have got everything set up that we need to have set up, and so we will be able to start the labs this week. So for those who are scheduled to do who have volunteered to be part of the overflow slot today from 12 to 2. Ms. Hogan will be seeing you there, and there will be TAs in the lab, and I'm going to try to drop by if I can at all. I do have other lectures that are happening, so I definitely can't be there from 1 to 2, and it may be hard for me to be there very much between 12 and 1, but I'm going to try because I really want to actually meet you folks and see your faces and stuff, and see you engaging with the material and doing programming in the lab and making lights turn on and doing exciting things for the first time. So I'm going to try if at all I can. So we do have those overflow slots plus the regularly scheduled slots, and we're going to use all of that extra spread out time to make sure that we can keep people spread out, we can keep our numbers low, and we can basically do this absolutely as safely as possible. Everyone here everyone who is registered in this course still should have 2 doses of an approved COVID-19 vaccination, and there are booster clinics that are happening too. So, do get one of those and try to keep us all safe. I would ask everybody, there's not at all a mandatory thing, but I would really ask you to consider, before you come back on campus, to install the COVID Alert app. I'm a privacy and security researcher, and privacy is a huge thing for me. And I have to say that, while I might have minor qualms about the VaxPass thing, the COVID Alert app is like gold standard, better privacy than pretty much any other app you could imagine installing on your phone. It's really, really that good. So please do consider installing the COVID Alert app, because it could really be helpful if we were to get into a situation where somebody in a class has a positive case. So that could really help us out. Again, not mandatory. It's your phone. You can do what you like with it, but I would ask you to consider it, please. Let's see. There's a question. Is there a pre-lab? I don't believe you are required to submit a pre-lab in advance for this particular lab. Those requirements may be evolving as the time goes on. Also, lectures. So lectures, as we've said before, are going to continue to be online because this is a large class, so there's more than 100 people. Therefore, we won't be having in-person lectures with everybody in the room. But if you're on campus, it looks like we are probably, and this is still being like finalized, but I've got the tentative go-ahead. It looks like in addition to the study spaces that I showed you in a previous lecture, it looks like we will be able to actually use our regularly scheduled lecture theater, not for me to stand in the room and talk to you, but we will be able to put up the lecture live stream on the big screen. And so, if you're over in arts, you can go to a study space and watch it in arts. If you're over in chemistry physics, you can use a study space in chemistry physics. But if you're in the S.J. Carew building, because there are a bunch of people who are going to be doing labs and stuff, you'll actually be able to go to our regularly scheduled lecture theater, EN 2006, where we will put this lecture up on the big screen. So instead of 40 people sitting in a room with headphones, you'll be able to actually just listen to me over the speakers. And when I say something funny, which I obviously do a lot, you'll be able to laugh together and things, and hopefully that'll be kind of a nice experience for those who are on campus. If you don't need to be on campus, you definitely do not need to come and attend that. That is purely a thing to help the people who are going to be on campus because of labs and lectures and smaller courses and that kind of thing. At the moment, the goal is to try to minimize the number of people we interact with. We're going to have to interact with more people than we have over the past few weeks, but we're not looking to go from 0 to 130 all at once. Okay, there's a question here. Are there any programs we need on our computer before the lab? No, you're going to be using the computers in the lab. So CSF 2112, those computers are now all set up, ready to go, and you're going to be using software on those computers. So you don't need to bring any computer at all, much less with any particular software. That said, you're going to see some steps that you can take in the lab, which you can take on your own computer if you want to, so that you can program your Grove device from your computer afterwards. Should we have received an email if we were to go to that overlab? I ticked off that I'd be able to attend, but I didn't get anything saying I was put in that lab slot, so I'm nowhere near town today. If you didn't get an email, then just go to your if you didn't get an email, you don't have to go to the overflow slot, just go to your regular slot. If you didn't get an email, but you are available for an overflow and you'd kind of like to, you can always send always send an email to the lab instructor, and Ms. Hogan would be very happy to correspond with you about your situation. If, however, you're out of town, like the person asking the question, then don't worry about it. Is there a possibility that lectures go in person after midterm break, considering restrictions are being lifted steadily around the world? Your guess is as good as mine. I am going to guess. I would say that is not super likely to happen, but it is possible that it could happen. I think the current guidance is that classes with more than 100 people, we are not going to make everybody come and sit in a room together. Whether there's a possibility of after midterm break things changing so that people can opt to sit in the room together while others opt to watch from home, I don't know. That's in the realm of possibility, but certainly I have no information to say that that's what's going to happen. So stay tuned. Lots of things can change. Let's see. Thanks and okay, thank you. You're welcome. Okay, so that's it about the exercises, that's it about the labs, and that's it about the lectures. So today, that's not quite it about the lectures. Now we're actually going to have a lecture. Da-da-da-da. So here we go. So let's talk about variables. So remember, what we've been talking about all the time that we've been together thus far has been expressions, Python expressions, building on our understanding of mathematical expressions. So Python expressions are in some ways like mathematical expressions, and in some ways really, really not. In both cases, expressions are values and operations that evaluate to a value. Now, I do not expect anybody to memorize specific definitions. So when we get to evaluations such as midterms, I will ask you questions that test your understanding of these concepts. I do not expect, in fact, I don't want you to waste your time well, I shouldn't say that. For some people, memorizing things is a particularly helpful way for them to learn by their learning style. So if you want to memorize things, fine, go ahead and memorize things. But I'm not expecting anybody to memorize a specific wording of any specific definition, but you should understand these concepts. So I will not ask you a question where I say define an expression and require you to repeat exactly these words back to me. I may, however, ask you, is this an expression? Is that an expression? Etc. Actually, you know what? That's a really good idea. I should ask you, is this an expression? So let me present a question now in Top Hat. Oh, and by the way, if you missed a Top Hat question in the last lecture, they've now been assigned. I believe I've assigned them all. So if you didn't get to answer it, then you should be able to answer it now, and I think it's due on Friday at 11. Again, I'm going to keep kind of short accounts on this. If you don't get the Top Hat questions in a particular lecture, then I'll give you to the next one, or maybe the one after that. We'll see. I'm not going to leave these questions open for weeks at a time. And that's to try to keep everybody on track, keep us all approximately in the same place. There is some synchronization and timing stuff that we really do kind of care about for this course because we have to keep the lectures synced up with the labs, etc. But again, if you're in a particularly special circumstance, and I know there are people who are still trying to travel here and they have international travel issues that are definitely not their fault because the world is complicated at the moment, do reach out. But otherwise, by and large, if you're just sitting at home somewhere in St. John's or in CBS or what have you, you can answer the Top Hat questions within a couple of days after the lecture. All right, so people are answering which of these are Python expressions. And I'm going to go ahead and close this in just a few seconds, and we'll see what people had to say. And once again, if you didn't get the question, I will assign it afterwards as homework. So let's close this in 5, 4, 3, 2, 1, and close. All right, and let's have a look at these. Okay, so interesting. So if we look at our definition of an expression is values and operations that evaluate to a value, and we said the very simplest expressions that we can see in this course are, the very simplest expressions that we'll see are just values. For example, literal values. And so literal values can be ints, floating points, imaginary, they can be strings, they can be Boolean literals, but that means that in fact a literal is an expression. What is the value of the literal 42? Well, that expression, it's a tiny little expression, but it is an expression, and it evaluates to 42. It evaluates to what it literally says. And so actually 1 is in fact an expression, a very, very simple expression, but it is an expression. We also looked at different kinds of operations that we can perform on other values, on values. So we can have arithmetic expressions, a value plus a value modulo a value to the power of a value. All of these are expressions. So examples of that would be 1e10 plus 50e9. Those would be examples of, that would be an expression. We have a literal value here and a literal value here expressed in scientific notation, floating point values, and they're added together. So that's an example. Here we have a more complex expression. We've got division, addition, exponentiation. Here we have an example of the unary negative, so not subtraction, but negative, right? This is a unary operator. It takes one operand, -1. So that's an example of a more complex expression. We had logical operators and or not an exclusive or. So true and false. So true is a Boolean literal. False is a Boolean literal. True and false is a logical expression. 1 plus 2j we saw earlier is a literal. It's an integer literal plus an imaginary literal. So that's an expression. And then finally, we looked at function calls. So the operations that we can perform are arithmetic operations, comparators, logical operators, and function calls, which means that the square root of 24, we take the integer literal 24, we put it into the input of our little square root box that says, hello, I will compute a square root. If you give me an input, I'll give you an output. Whatever the output of that function is, that is what this expression evaluates to. So the answer here is that actually all of these were expressions. So let's see, we've got a couple of questions here. Will we need Arduino Uno R3 for the first lab? So it is preferred if you bring the kit that has been recommended for this semester, the Grove Beginner Kit. So this thing, if you don't have that thing, please email the lab instructor to make sure that she is prepared to support you. If you have, for example, this thing plus this thing, which is what students were using before. If you have those things, there are some slight differences. We may still be able to accommodate you. We may not. So please email the lab instructor. Someone says, okay, we don't need to purchase the other parts students had last term. Nope. This kit, one of the reasons that we really like it is that it comes with absolutely everything you need. So this device, so this old Arduino is kind of included right there. So this bit is the Arduino, plus it's the little Grove shell that used to be on top, and a bunch of these devices around here are things that used to come in a separate box. This is all in one. You don't even have to plug things together, and it's also a whole bunch cheaper for you. So hooray, that's why we like it. And it's got a nifty little OLED screen with a much higher resolution than the old device. Okay. So I'll leave those lab questions for now. Any other lab questions about equipment, etc., your specific equipment? If you have anything other than the Grove Beginner Kit that you bought from the library, then please email the lab instructor so she's aware, and then she can make sure that you're sorted out. Okay, so this is what we've been talking about thus far. All of these different expressions. So values, operations, and how those things evaluate to values, kind of like in math. Now we are going to talk about something new. We're going to talk about variables. And variables which are in some ways similar to mathematical variables, but in some ways quite different. This is an example, by the way. So in one of the Top Hat exercises that people had to submit the thing about look around you and look for computers this week, etc. I've posted some feedback on that question. I've now graded everyone's. So you should have some feedback on that in Top Hat. One thing I'll say, just generally. And on this particular slide, I was being deliberately silly. It was kind of Dickensian. If you read, the Pickwick Papers or something by Charles Dickens, you'll see these ridiculously long chapter titles that it's like it almost describes everything that happens in the chapter. So I'm being deliberately silly here. But when you are doing technical writing, we are not overly enthused about the loquacious vocabulary with which one expresses longitudinally complex concepts. Use short, simple words wherever you can. We are not looking for, in technical writing, big words. We are not looking for very, very long, complex sentences. We're not looking for grand pronouncements where we say, in this modern technological age, we are all utterly dependent upon technology in all of its forms. I'm actually looking for, when I ask you, how have you been influenced by technology this week? First of all, you can speak in short, simple words. That means the meaning has nowhere to hide. Sometimes people use big words when they're not confident that they have the meaning, so they use big words instead. Not always. Sometimes big words are appropriate, but sometimes we can use big words to try to hide the fact that we're not sure that we've actually answered the question, and do be specific and concrete. So lots of the answers that I read were, thoughtful and you'd done some reflection. Some of the answers contained details that I learned something, or something that I was kind of surprised by, or something that I wasn't surprised by, but really, really pleased to see that you were kind of really engaging with stuff and learning from the questions that were being asked. So people talking, there was one student who talked about, the washing machines not working this week because a computing system was down, and so they couldn't do their laundry in like the residence or the building that they live in. I'm like, wow, what a not very surprising but still shocking kind of dependence on computing. Someone talked about how they and their partner Googled the same term and got completely different answers. And what an interesting little specific point from your particular life, which kind of makes a larger point. So it's always good in technical writing to focus on real details and to speak as simply and clearly as possible. The best answer is the shortest one, which contains the thing that you're trying to say, which conveys the meaning. All things being equal, if you convey the same meaning with a short paragraph or a long paragraph, the shorter one is probably better. In writing, people will sometimes say less is more, and that's why. Okay, that's it. I mean, you may still have gotten 2.5 out of 3 if you did write very, very long sentences, but you don't need to. And in fact, in technical writing, less is more. Okay, so let's go back to variables. So we've previously used variables, right? So I have opened Thonny in the past. Let's see. I've opened Thonny in the past and said things like, well, we can get some variables from math. So let's do it this way. From math import star. And then we have variables like pi and e and tau that we can use inside of mathematical expressions. What's 2 times pi? What is tau divided by pi? Well, that should be 2.0. And yes, indeed, it is. So we've used variables before, but now we might reasonably ask, where is it that variables come from? And some clever person amongst you will probably say, well, you told us that as a short-term little hack without having to have full understanding. I could just write variable name equals something, and that's true. But now we're actually going to understand these things in a little more of a holistic way. So first of all, let's ask, what are variables, both in mathematics and in programming? So what is a variable in mathematics? You've all done lots of math. What's a mathematical variable? Some folks are typing. That's good. Oh, some folks are still typing. So, very detailed answers I guess we're going to get here. Okay, so one thing that a variable can be is a stand-in for a number. Good. Something that represents a value. Yep, okay. X and Y are examples of variables, and we often, by convention, use X and Y for an independent variable and a dependent variable. Yep. So a character, so a name that represents a value. In math, it is often a single character. It might be a single Latin character, like X or Y, or it might be a Greek character like pi or theta, something like that. Something to which a value can be assigned. We're starting to get into programming there, aren't we? But in mathematics, so it's a name for something. And so it is very often a name for a variable, but often, it's not just a name for a variable, it's a name for an expression, right? So I could define x, and I might say, let x be equal to 4 pi y, let's say. And then if I wanted to, I could rearrange that equation, right? I could say y is equal to 4 pi over x, right? And so then you could imagine that if we wanted to, we could graph this, and we have a slope of negative 4 pi. So it's going to kind of like, whoops, there shouldn't be a y-intercept in that. There we go. So that should kind of look like that. All right. So we can play with variables that way. I can use variables as stand-ins for more complex expressions. So a variable can just be a single number, but a variable can also represent a more complex expression. So if we say that theta is pi over 2, then theta can be seen as a placeholder for the value pi over 2, or indeed as the expression, the symbolic expression, pi over 2. So here theta is a placeholder. We can also do things like substitute theta for pi over 2. So if we have a mathematical expression that contains pi over 2, then maybe we turn that into, in this case, theta plus sine of 2 theta, because this could be pi over 2 plus sine of 2 pi over 2, so theta plus sine of 2 theta, right? And the variable and the expression that it is equal to are exactly interchangeable. Whenever we see one, we can remove it and replace it with the other. So sometimes we take the variable out and we substitute in the thing that it is equal to. And sometimes we take an expression and we remove that whole expression and we substitute in a variable. Right? So a variable is a placeholder for an expression. It is also the case. Oh, sorry, there's a couple things in the chat. So somebody had x over 4 pi. Okay, yeah. So we also have, let's see, don't forget the negate. Well, anyway, the inverse operation there. But also we have in mathematics, when we write an equation, we're making a statement of truth. We're saying it is true that x is equal to 4. And in this case, saying that x is equal to 4 is exactly the same thing as saying that 4 is equal to x. However, in computer programming, we are going to see that things are slightly different. So first of all, try opening up a Python interpreter right now. You've got a computer in front of you. So whether it's Thonny or whether it's one of the online interpreters that we have, try opening up a Python interpreter and write x equals 4. And it should do that. But then try writing 4 is equal to x. And tell me what you see. Somebody type in the chat what you see when you type 4 equals x and press enter. Right, we see an error. Okay, and what in the world does that mean? It says syntax error, can't assign to literal. So what is a syntax error? We've talked about the difference between syntax and semantics. So what is syntax, or what is a syntax error? All right, so syntax is the rules of a language that says what makes well-formed language. So, for example, some languages have a particular order of like subjects and verbs and objects. So in English, we typically say subject, verb, object. John throws the ball, for example. And in other languages, you can have other orders. And in some languages, you can have almost any order because there's extra clues built into the language. So I think Latin is kind of this way, which is maybe why they used to want everyone to study it in school. You could put words in almost any order you like because they have all these extra clues embedded in the word about which thing is the object, etc. Hence declension, which is apparently a thing that one does to a noun. But yeah, so a syntax error means that we are breaking the rules of the language. Never mind the meaning of it. So semantics would be more like what value do we want to assign to this number, to this variable x. So the semantics of this first statement is saying we are going to have a variable called x. We're going to put the number 4 in that variable. But syntactically, never mind what the value is or what the meaning is, this is just not allowed by the rules of the Python programming language. So why not? Because in programming, in lots and lots of, and I would almost say all programming, but there are a couple of really weird programming languages, some of which are deliberately weird. But in like 99% of programming languages, a variable means something different from a mathematical variable. A variable in programming is not a placeholder for an expression. It is a place in the computer's memory where we can hold something. So, whereas in mathematics, we were writing things like x equals 4 and 4 equals x, and these kind of mean exactly the same thing. In programming, when we write x equals 4, what we're really doing is saying, dear computer, I want you to make sure there's a place in memory. I'm going to draw a little box here, and you're going to see lots of boxes with names next to them. I'm going to call it x, and I want you to take the number 4 and put it in the box. Okay, that seems pretty straightforward so far. And so every variable has a few different things, a few different characteristics. Let me just put myself away there. So a variable has a name. So in the case of our little variable x here, the name is, well, it's x. So I've drawn a box and I put the number, or the number x. I've put the name x next to it. And that name doesn't have to be something as short as x. It could be something like course. So the course is equal to 1020. What does that mean? Well, that means I'm going to make sure that we have a box over here in memory, a place in memory where we are going to store something, and I'm going to put the number 1020 in it to start. So a variable has a name, it has a value that it is currently storing, and that value has a type. So if I wanted to, in Thonny, say, let's say course is assigned by 1020, I could say, what is the type of course? And what answer would we expect to get? Yeah. 1020 is the value. The type is int. So just like the type of 1020 is int, the type of course is int, because course currently holds the value 1020. Now notice that I said it currently holds the value 1020. So the variable has a value in it, and that value has a type, but that value can change. So this is something in which this is one way in which programming is very different from mathematics. So if I were to write in math that x is equal to 4, and then I were to write that x is equal to 5, what does that mean? well, I'm going to like unravel the fabric of space-time or something because I have made two statements of truth that are contradictory, that x is equal to 4 and x is equal to 5, right? That would imply that 4 is equal to 5, which means that 1 is equal to 2, which means, no, sorry. As math goes, that is not good. We don't do that. However, in programming, if I say x is, and I'm going to say assigned by 5, so the equal sign, the single equal sign means we're going to take whatever value's on the right-hand side and we're going to assign it to the variable that is named on the left. So what does this do? Well, there's no problem here in programming. This means that x used to have 4 in it, but now we're going to erase that 4, and now we are going to write the value 5. So this is one way in which programming is quite different from mathematics. In Thonny here, I'm going to go to my View menu and look at the variables. Actually, there are a whole lot of things here because I imported math, so let me just restart that. There we go. Now it's nice and clean. So I'm going to write x is equal to 4, and you'll see there's now a variable, a place in memory to store a value, and it currently stores the value 4. I can also write x is equal to 5. And what happens? Well, x is now still a variable, but all we've done is replace whatever used to be inside of it with the number 5. I'm saying course, not count. Yeesh. Course is equal to 1020. Well, that is course is assigned by 1020. So we take whatever expression is on the right and we assign it to the variable on the left. So if I type course, we've seen it says int. What happens if I do this? So I'm going to say course is assigned by the string literal ng1020, and then I'm going to say what is the type of course. What do you think is going to happen? And there's a couple of different possible answers, and there's a couple of different plausible answers. So feel free to make a guess, and even if the guess is wrong, that's okay. We're learning. Sometimes, believe it or not, it can actually really help you to learn to make a guess at something and then be wrong about the guess, and then learn the right thing. Sometimes you will actually remember that lesson better for having gotten it wrong the first time. So actually being wrong and making guesses and not feeling like you have to be right all the time and I have to get 100% on every guess, that can actually really help you learn. So feel free to make wrong guesses. So we've got a few possibilities here. Oh, someone said, how do you open the variables tab in Thonny? So on the main menu in Thonny, which you can't see because it's just off screen, I'm clicking on view here. So there's a file menu and an edit menu and a view menu. And under there's a whole bunch of different things that you can open, including the variables little tab. Okay, so yes, we've got some guesses here, and it looks like they are mostly right. So it seems that people here have some either Python experience or just making good guesses. If you came from like a C++ background, you might have thought this could be an error, because in some programming languages, you're only allowed to store variables of a particular type, or values of a particular type in a variable. But in Python, we can take the old value, which was an int, and replace it with a new value, which is a string. So the type, it's not the type of a variable, it's the type of a value, the value that currently happens to be stored inside that place in memory. So a variable is just a name for a place in memory where we store a value, and we can change that value. And that is something that is different about programming. In math, if we wanted to do something like that, I guess we could write that x prime is equal to, that x is equal to 4, and then maybe we could write that x prime is equal to 5, and x double prime is equal to 6. But in that case, x and x prime and x double prime, they're all related to each other, but they are in fact different variables. Whereas in programming, when we have multiple assignment statements, we take the value on the right and replace whatever is currently inside the variable. So this is our first use of Python statements. So we've seen Python expressions. Python expressions evaluate to a single value. Well, a Python statement is something that has an effect in Python, but is not an expression. And examples include when we write a Python file, each line in that Python file, sort of more or less. It'll be a little more complicated than that, and we'll get to it. But to start with, we'll say each line in that Python file is a statement. Now, that statement could be just an expression, but usually it's something more, such as an assignment statement. So let's see. Math variables are like writing on paper in Sharpie, so it can't be changed. Programming variables are more like containers. You can place that paper in and swap it for another. Yeah, that's a pretty good way to think about it. So good, thank you. It is indeed a place. It's sort of like a box on a whiteboard that I could put a sticky note in, and if I wanted to, I could take that sticky note down and put in another sticky note. And so this picture of a box with a name next to it and a value in that box is something we're going to use a lot. And believe it or not, many students get into trouble when we get a little further in the course and I say things like, what will this program do, this Python program do? What will the behavior of this Python script be? You can get into trouble if you start. People will often think about variables like mathematical variables, and they look at this big complicated thing and then try to figure out, okay, based on whatever this was and this was, what will this value be at the end? Instead of doing the simple thing, like a computer does, simple but tedious, but that's the way computers work. They're simple but tedious, and saying, okay, here's my box, here's the value that's currently in it. Later in the Python script, I update that variable, okay, here's the new value, etc. Here's a really useful, well, actually, no, sorry. Let me finish this slide and then I'll say the other thing I want to say. So this is an assignment statement, and an assignment statement has two things. On the left-hand side, we see the name of a variable, and on the right-hand side, we have the initial value that gets stored in the variable. So this is why, although we can write x is equal to 4, or x is assigned by 4, we can't write 4 equals x. That doesn't make sense, because this statement is not saying x and 4 are equivalent. They're exactly the same thing. You can, whenever you find one, you can replace it with the other. No, an assignment statement is saying take the value of the expression on the right, and that value could be more complex, right? It could be x is equal to 2 plus 2. Well, we're going to evaluate that expression, 2 plus 2, and assign it to the variable x, and we still get the number 4. But we can't flip those around. We can't say 2 plus 2 is equal to x, because that would be saying, here's a variable, and the variable is named 2 plus 2. That doesn't make sense. And we're assigning it with x? No, sorry, that really doesn't work. So we have a name of a variable, and we have a value in the variable, and that's the initial value. And the reason we say initial value is, well, as I've put on the whiteboard already, the virtual whiteboard, in math you can't say n is equal to 1 and n is equal to 2, but in programming, sure, we can do that all the time until the cows come home. We can say n is 1 and then n is 2. Now here's an example. Okay, so there's a question here. If we assign a variable to a variable, what is the type going to be? Aha, excellent. I'm glad that you asked that, because that goes exactly to what I was going to say next. So let me once again just restart this so that we see there are no variables here. Put all that away just by holding enter a bunch of times. Okay, so let's try this. If I say x is equal to 21, and then I say y equals x, what's the behavior of this going to be? In fact, you know what? Let's do it this way. I'm going to write that in the script, x equals 21, y equals x. And I'll save that as demo.py. There we go. And now I am going to click debug this script. And that will let us run this script kind of one statement at a time. So you see there is this step into button in the middle here, or also it's F7. So I'll press F7, and this will step through the execution of this statement. So first of all, x is equal to 21. Okay, well, what is the value of on the right-hand side of this assignment statement? And the answer is 21, and so we're going to store that in a variable called x. Next, y is assigned by x. So the first thing that the computer has to do is to evaluate this expression on the right-hand side is to say, well, what is x? How does it figure out what x is? It's going to go look in the box. It's going to say what value is currently being stored in that variable called x. And the answer is 21. So y is assigned the same value, 21. Let's say there we go. And then let's print y. Okay. Think for a second about what this program will print. So we've seen the print statement before, so we can pass kind of any value we want to it. Print hello, and it will just print that value. So if you were to run this Python script one statement at a time, just work through it and use a piece of paper if you like. Write down what's in each variable and figure out one statement at a time. What is this going to print? All right, so we will debug this script and walk through. So again, x is assigned by 21. We evaluate the right-hand side, and the right-hand side is 21. So we take that and assign it to x. Boom, we've got a variable with x in it. We then execute this statement, y is assigned by x. So we take the value in x, the value that is in x right now, and that value is 21, and we assign that to y. Now, we're going to change the value in x. We assign a new value to x. Whatever's on the right-hand side, well, that's 1020, and we assign that to x. And so now we have x is 1020, but notice we didn't change anything about y. So if this were math, and we said x and y are equal, and then we say something about x, well, that goes for y as well, but it doesn't in programming. So when we print this, and it looks like there's some disagreement and some different guesses about how this is going to work, when we print the value of y, we're going to go find what is the value of y, and the value of y is whatever is in the box, and the answer there is 21. So this will print 21. And that's an important distinction between how mathematical variables work and programming variables. So I would suggest, if you didn't quite understand how that worked, then after this lecture, write those steps down and work through it yourself and try it again. And this is true even if we do other things like x is equal to x plus 1. Which, again, in math, well, there's no way you could do that, right? You can't say that x is equal to x plus 1. That doesn't make any sense whatsoever, unless x is defined within a certain group that, well, anyway. But here, we're going to assign the value 21 to x. Then we take whatever value's in x and assign it to y. Then x is equal to x plus 1. What in the world does that mean? That means take whatever value's on the right and assign it to x. So what value's on the right? Well, it's x plus 1. What's x? X is 21. So 21 plus 1, well, we can figure that out. That's 22. And 22 is then assigned to x. So again, we print y, and y is still 21 from earlier, but x is now 22. So this is a key way that programming variables are different from mathematical variables. Someone said, because that's the value stored in its memory? Exactly. We need to think of variables as names for places in memory where we store values. Someone said, what is the step to get the current value of x in y? Do you mean on line 2? So all we did there is we're assigning whatever's currently in x and putting it in y. And so whatever value is currently in x, well, how do we get that? We look at whatever is written here. So if I were doing this on paper, I would have a little box, and I would say what number is currently, or what value is currently in x. And that is all because that is exactly what the computer is doing. The computer is not stopping and reasoning about, well, is y the same as x, and where's all the... No. All it's doing is saying, you reference something called x. I know what x is. It's a place in memory. It's got a value. I will go get that value for you. Okay. So that's some important stuff to think about with variables. We'll talk about more stuff about variables next time. But for now, I'm going to leave you with some exercises. And these are not exercises that appear in Top Hat or in Gradescope that you get credit for doing. These are just good exercises for you to do for yourself and maybe compare with your friends or something. But in a Python interpreter, define 4 variables and give them whatever names you like. And in fact, it would be kind of fun if you experiment with different variable names, and you're going to see some variable names are okay and some things that you might like to name variables are not okay. We'll talk about why on Wednesday. We'll introduce the rules for what makes a good variable name, what makes a syntactically legal variable name. But for now, just try a bunch of things. You've seen X and course, and just try lots of different names and see what will work and what won't. See if you can find any patterns in that. So define 4 variables, one that has an integer in it, one that has a floating point number in it, one that has a string in it, and one that has a Boolean value in it. And then for each of these variables, change their types. So change their values, put another value in with maybe the same type or maybe a different type. And in all of these steps, just check their types using that type function. Once again, the way to succeed in this course is to be actively engaged in it. If you just sort of passively sit there and say, yeah, that doesn't so bad, I could, that doesn't sound so hard, I could do that if I had to, that might be true right now, but if you go too many weeks with that, you'll come to a midterm and say, oops, I wish I had actually practiced some of this stuff. Whereas if you engage with these exercises really actively now, you're going to find when you get to the lab or when you get to the midterm, you're like, this is really trivial. I don't understand why this is hard, because you put the work in up front. So please do these exercises. It's for your benefit. I don't get any benefit from you doing them other than the satisfaction of seeing students do well in the course, which is something that actually really motivates me. I would really like you to do well, but it's up to you. Okay, so that's the end of the lecture for today. If anybody has questions, I'll stick around in the chat for a few minutes and answer them. Let's see, if there are any questions that people want to ask right now that seem generally useful, then I'll maybe even answer them live. Some people are going to be in the lab in 9 minutes, and I hope to be able to see you there for at least a few minutes. I do have to do a lot of prep work for my other course, but hopefully I'll get to see you there for at least a few minutes. So questions here. What is the step to get the last value of X in Y print? Okay. Not quite sure I understand that. But yes, as someone said, the print function will output something to the shell when the program runs. Yes. So when you say, I'm going to run this, it will print stuff. And you can actually print multiple values if you want to. Let's start by doing it this way. I'll print a string that says the value of Y is, and we can print in fancier ways than that too, but here you'll see the value of Y is, and then it prints out 21. Is the exercise available? So the exercise, if you go to the course website, you'll see at the end of the slides, you will see this exercise. So it's not, something that is written down in a place that you have to submit or anything. This is just an exercise for you to do yourself. Oh yeah, someone said, will we go over the truth table from previous lectures? Yes, that would be a really good idea. Unfortunately, we're out of time today. So we'll see. Maybe we'll start Wednesday with that. Yes, thank you for reminding me about that. Sorry that I didn't remember until we were out of time. This is a silly question, but why is there a variable called nan with value nan within the math variables? Yes, that's a fair question. Why is there a value called nan and not a net variable called pop? That is fair. From math, import star. So if we do that, we'll see there are lots of variables here, including e and tau and pi. There's also one called inf, and we'll see that the type of inf is a floating point number, and that is meant to represent infinity. So if we say 1 divided by 0, well, actually that's not going to be allowed. We can't have 1 divided by 0. But there are some floating point operations that can result in a value of infinity. 1 divided by 0 isn't one of them. But also there's this variable called nan, and that is also a floating point number. Now, we'll talk more about these things at the very end of the course, but for now, know that nan is short for not a number. So there are circumstances in which you might have a mathematical expression that can yield a result which is, well, there's no valid mathematical result. So what do you do? Well, there's a special floating point value called not a number. So 4 times not a number is also not a number. 3 plus infinity is also infinity. So inf and nan are short for infinity and not a number. Great question. Shows that you're actually digging in and playing with these things, which is exactly what we want. All right. Somebody reacted with a nan emoji. Very nice. Gordon Nan's house. Have a feed. Have a scoff. All right. So that's going to be it for today then. So thanks very much for tuning in, and I'll look forward to meeting some of you in the lab in just a few minutes, and others hopefully throughout the week, depending on exactly which slot it is. So have a lovely rest of your day.